Welcome to Laser Damage for Optical Coaters. My name is Kieran Ross and I work at BRL, where we damage optics for a living. In this video, we go through the data and sample requirements for a laser damage test. Just for your entertainment, we have short videos of damage taking place. We've all done it. An optic we've been working with has damaged, and we have to source a new one. Imagine the cost in time and money if that damaged optic had been inside the laser itself. Perhaps in your case it was. This is an intracavity Q switch called lithium niobate. It is a coated electro-optic crystal. Lithium niobate can damage at the front face, or at the rear face, or even inside the crystal itself. Here it is before, and this is the damage event filmed from above. This is extensive damage, which is due to both the substrate damaging and the surface ablating. Let's look at what a good test house can give you, the coater. Our function as a laser damage test house is to classify optics with respect to laser use. We have two main types of accreditation. A pass-fail certification, where we certify at a given power level, and a more expensive test, in which the coating run can be identified with a particular power resistance. This is a threshold test, formerly called Laser-Induced Damage Threshold, or LIDT. Additionally, BRL can provide a number of non-standard functions and R&D support. Most coaters supply a witness piece of approximately 20 mm in diameter for a full threshold determination. The sample must be planar to ensure an accurate test. Coatings can be anti-reflecting, totally reflecting, or partially reflecting, and they can also be polarizers. So we need to know exactly what they are and how you want us to test them. Our order forms are available on our website, and we can talk you through how to fill them out. For LIDT tests on AR samples, it is very important that both faces of the sample are clear. A ground glass rear can reflect energy and your coating can damage prematurely. For LIDT tests on HR samples, a clear rear face is also preferred, as again, reflection during damage gives larger damage sites and contaminates the limited test space. Now just a word on sample quality. Many coaters think they can send us a physically damaged sample, and that's okay, it's only for a test. But in reality, it's always best to follow one simple motto. The better the sample, the higher the threshold value. Scratches and digs can cause damage, and once we detect a damage event, it cannot be ignored. Sometimes coaters don't have a witness piece. Some optics can be tested, but not curved ones. We need all the info that you can give us, both about your sample and its test conditions. This is our eye-catching order form for pulsed laser damage, which is by far the most common test. It is all the standard info we need to complete your laser damage test. Please talk to us. We can save you a lot of time. We now need to give you a small but important mention about units. Peak power density is the critical factor causing pulsed laser damage. Coating technologists receive their instruction from laser physicists. who like to speak of damage in terms of joules per centimetre squared. However, without specifying the pulse duration, this value is meaningless. Physicists and coaters often don't speak the same language. Luckily, we are bilingual in this respect, but a technical drawing can be a great translator. BRL gives you results in both joules per centimetre squared with pulse duration and in watts per centimetre squared, catering to both the physicists and the coating technologists. BRL have high quality in-house experience in solid state physics, laser physics, and materials. We feel able to support coating development by providing very accurate, timely results. Here is the damage profile. We give in-depth detail with each certification. In this case, a graphical determination was possible, and graphical results are far more informative than least fluence. Least fluence is the highest tested value which did not damage. But a graphical result will give far more diagnostic information. The damage pattern, slope, and pre-slope events give vital information about your coating quality. You can see here clearly marked the damage threshold, which is the highest power density that your sample can handle without damaging. Now we will look at CW damage. In general, damaged test sites cannot be seen with the naked eye. But here we have used a material which exhibits clearly the damaged sites. The larger sites are due to ablation, which can always be seen with the naked eye. Arrays of normal damage test sites are shown on this sample. The ablation power used here was at least 50% above the total failure point and was enough to fracture the substrate. Here is a video of that ablation. And this was it before testing. Both CW and pulse tests are done to ISO standards. CW is very different from pulsed, and few people are interested in CW tests. In fact, they only account for 5% of our total. CW tests are an order of magnitude harder to perform than pulsed. Our website gives a detailed account of what's involved, including the test units, which are different from pulsed. Each CW test report gives the end user a ready reckoner, as unlike pulsed, CW damage is dependent on beam size. Our white paper is in May's edition of Electro-Optics magazine, so if you missed it, see our website. The link is given here. We at BRL have a good, responsive relationship with all our customers. But that's you, the coater. We can give advice before test and after test. Or we can explain your test results and any comments we have regarding your samples. We pride ourselves on giving more than just a number. And finally, as many of our viewers will know, BRL is recommended by large laser producers in both commercial and defence sectors, where we can boast zero failures in the field.